So we start the second part of fundamental forces. Already we discussed in the first part gravitational force and electromagnetic force. So now we have the third force, which is called the strong nuclear force. Already it's a nuclear force and it is very, very strong. It is a nuclear force and it is very, very strong force. But this is a very short range force. It remains only in a very small region, the region of nucleus. It is within the nucleus, means in the 10 to power minus 15 meter. The force can be felt, the force can be observed. So, or you can call it 1 Fermi. 1 Fermi is equal to 10 to power minus 15 meter. So this is the range, this is the domain in which you can observe or you can feel the presence of strong nuclear force. This force exists within the nucleus. So very important force, and because right now all over the world the people are interested in quantum mechanics, the people are interested in nuclear physics. So all both these sciences they deals with the elementary particles. In quantum mechanics also we deal with elementary particles, and nuclear physics also we deal with the nuclear dimension object, nuclear size object. So it becomes very important to study the nuclear forces and their properties. So let us go for that. So this force basically it can be observed within the nucleus. So the attracting force between nucleons. Nucleons means, what is nucleon? Nucleons means this nucleon means the constituent of nucleus, protons and neutrons. So they make nucleon. So here we are studying the force between proton and neutrons. So here the proton and neutrons, depending upon the atomic number of the element we are studying, so these will exist in pair. So we can have proton pair, we can have proton neutron pair, and we can have neutron pair. So these will exist in pair. Now you see proton and proton, they are positively charged. So we also know from the electrostatic or from the Coulomb law, so like charges they will repel. So they should repel, but they are not repelling, they are attracting. So there is an attractive force between the two protons. So another is the proton and neutron pair. So here a neutron is also attracting a proton. Proton is also attracting a neutron. So how a neutral can attract, or how a neutral can be attracted by a charged particle? Similarly, in the neutron case, both the particles are neutral, but still they are attracting each other. So the Coulomb law fails over here. So a new science start working when we take the domain of nucleus, and in that domain only the forces are attractive, and the proton they will attract, the proton neutron that will attract, even the neutron will attract. So here the Coulomb force is there, but the nuclear force dominant over the Coulomb force. Here there is no Coulomb force because they are neutral particle. Here there is no force because they are, one is positive and other is neutral. But in this case, the nuclear force dominate the Coulomb force. So that's why the repulsion is surmounted or overcome by the nuclear attractive force. So there is a new science, there is a new physics which is called the nuclear physics. In that physics, we study about the attractive forces of the nucleus. These are called the nucleon, the proton nucleon, proton neutron nucleon, neutron nucleons. So how the nucleons, they are attracting each other, that is the part of discussion. Okay. So nuclear forces are two types, strong nuclear force and weak nuclear force. So strong nuclear force and weak. So how one time the nuclear forces, they are strong, and in another time how they are weak. So let us study one by one. So first we will take the strong nuclear force. So the force between protons and neutrons inside the nucleus is known as strong nuclear force. So you can see the nucleus. So this is the nucleus. So here the proton, so they are shown by the positive charge and red color ball, small ball, and these are the neutrons. So the proton and neutron, they are bind together. You see, the proton, even the proton, they are bind together. The repulsive force between the protons, the two protons, that is surmounted or that is overcome by the strong nuclear force. And this whole thing, these nucleons, the pair of nucleons, they are present inside the nucleus. So these forces only work when the distance is 1 Fermi or 10 to power minus 15 meter. But if we move away from the 1 Fermi, then the Coulomb force will start working and the nuclear force, they will not work. So so what are the properties of strong nuclear forces? That is the main topic of discussion, the properties, because from the properties we will know the hidden things about the strong nuclear forces. So they are short range. Short range means they can be felt only in a region of short range. So what is that range? What is that range? It is 1 Fermi, and that 1 Fermi is equal to 10 raised to the power minus 15 meter, minus 15 meter. So this is the range. This is the range, 10 raised to the power minus 15 meter. So if we cross the range, then the strong nuclear force, they will not work. So they are called the short range because the distance is so small. It is the strongest of all the fundamental forces and has a range of 1 Fermi. It is the strongest force. Strongest force means even this force overcome or surmount the repulsion between the two protons in the nucleus. So that's why it is called the strongest force. It is charge independent. It does not depend upon charge. I already told you that proton, both the proton, they have a positive charge, but still the nuclear force of attraction is there. So that does not depend upon the charge. Even the force is there between proton and neutron. Neutron carry no charge, but still a charged particle is attracting a neutral particle. So even in the third case, neutron-neutron pair, there is no charge on the neutron, but still the force of attraction is there. Strong nuclear force of attraction is there. So it does not depend upon the charge, but it depends upon the spin. Spin means proton and neutrons, actually both the particles, they are spinning. So which particle having the which type of spin, and we know that spin is either the upward spin or the downward spin, either the clockwise spin or the anti-clockwise spin. So the charged particle, every charged particle that spin about its axis. So what is the type of spin? Upward, downward, or clockwise or anti-clockwise? So means the spin that will also decide the strongness of the nuclear forces. It does not obey inverse square law, means within the nucleus, if the neutron and neutron, they are at the center, then the force will remain the same as the force is on the edges of the nucleus. So wherever the charged particle in the 1 Fermi distance, so whether they are close to the center or whether they are away from the center, so this force does not depend upon that. In the center and in any part of the nucleus, the magnitude of the nuclear force, that is same. So it does not obey inverse square law. And in strong nuclear forces, what are the particles which are exchanging between two protons? So I told you that if we have proton-proton pair, proton-proton pair, so they are attracting. So something is moving from this proton to this proton, means from both the photons. And what are those particles? They are called the mesons. Likewise, in between neutron and neutron, the same meson. In between proton and neutron, the same meson. So these are the mesons which are exchanged between the charged particle, between the neutral particle, between the charged and neutral particle. And due to the exchange of these mesons, the attraction is there, the nuclear force, the strong nuclear force is there. Now to the next property. So before to the next property, let us take one question. Strong nuclear forces are between, these are between proton and electrons. These are between electrons and neutrons. These are between proton and neutrons, and electron and neutron. Proton and neutron, that is not possible because in electrons, they are not the part of nucleus. Electron and neutron, again, this is wrong. Proton and neutron, yes, this is the right answer. So proton and neutron, because they are the part of nucleus. Which of these is not a property of strong nuclear force? It is the strongest of all the forces. Yes, it is right. It is charge independent. Yes, it is also right. It has a range of 1 Fermi. Yet, yes, it is also right. It obeys inverse square law. No, no, it is not obeyed. Inverse square law is not obeyed because I already told you that within 10 to power minus 15 meter, wherever you take the nucleon, wherever you take the proton, neutron, neutron, any nucleon, so it will have the same force of attraction. So the nuclear force of attraction, they does not depend upon the inverse square law. Now final and the last fundamental force is the weak nuclear force. Already it's a nuclear force, but it is a weak nuclear force. The third one was a nuclear force, but that was a strong nuclear force. So it is a weak nuclear force. Now we will study how it is working. So the force between the elementary particles emitted during radioactive decay of a radioactive substance is known as nuclear force. So you can see it's a radioactive sample, and the radioactive sample continually, spontaneously, it is emitting the radioactive element. It is emitting alpha, beta, gamma, or many other type of radiations. So when the nucleus, because alpha, beta, gamma, they are the nuclear particle. So when any radioactive element is radiating alpha, beta, gamma, or any other particle, including the energy which comes out from the nucleus. So at that time, how the nucleons interact at that time of decay, how they are interacting. Because if the strong force is there, it means that strong force should not allow disintegration of the particles. But still, disintegration of the particles means conversion of one particle to the another particle is going on, and that is going on through a mechanism of the weak forces. So if there are weak forces present in the nucleus of a radioactive element, weak forces, they are only the concept of nucleus of radioactive element. But strong forces, they are not present. They are not the part of radioactive elements. Here the weak forces are working. So because forces are weak, so that's why the nucleus of radioactive material, that is disintegrating. Otherwise, if the forces are strong, then it's not possible for even for the radioactive material to disintegrate. They are disintegrating because the strong forces are not there, weak forces are there. So weak forces, they are the forces in the present in between the nucleons of a radioactive sample. or radioactive sample or the nucleus of the radioactive sample. Now, what are the properties of weak nuclear forces? It is a weak force of attraction between certain particles such as neutron, electron. How the electron is coming? Because in alpha, when we are discussing alpha, beta, gamma emission. So alpha means that is a helium nuclei. Gamma again that is the conversion of either of the proton or of the neutron. But how the beta particles, which are purely electron, how they are coming out from the nucleus? Because one proton or neutron, when they convert into each other, then they emit electron. So when they are emitting the electrons, at that time they are not the emitted electron, the converted electron, they are not binded with the other neutrons or nucleon present in the nucleus. So they will come out. So because the weak force of attraction is there between them. So this is responsible for beta decay, because electrons, they are not strongly bound, they are weakly bound with the neutrons or with the protons during the conversion. Electrons, they are not present in the nucleus, but the conversion of proton or neutron that produces the electron. So the electron produced, they will come out, they will decay. So it is stronger than gravitational force. It's not weakest force, but it is in comparison to the gravitational force, it is stronger than the gravitational force, but weaker than other forces. It is weaker than the electromagnetic force, and naturally it is weaker than the strong nuclear force. It is communicated through weak boson. So if radioactive disintegration is happening of the radioactive elements, so कौन से पार्टिकल हैं जो इंटरेक्टिंग पार्टिकल हैं? सो यहाँ पे जो इंटरेक्टिंग पार्टिकल हैं ड्यूरिंग द रेडियोएक्टिव डिके, दीज आर बोसोन. सो इट मींस रेडियो एक्टिविटी में बोसोन्स का निकलना कंफर्म है, बोसोन पार्टिकल पक्का यहाँ पे निकलेंगे. सो अब फाइनल, व्हाट इज द ऑर्डर ऑफ रेंज? ऑर्डर ऑफ रेंज मींस नाउ वी स्टडीड द 4 फंडामेंटल फोर्सेस, and every fundamental force that has its own coverage area, that is called the range of that force. So the highest range is the gravitational force, so I will take it at the first position. So second is the electromagnetic force. The second category of the second strongest or the longest range is of the electromagnetic. Then is the nuclear force, strong nuclear force, and then finally the weak nuclear force. So the longest range is gravitational force, after that electromagnetic, then strong nuclear, and then range of weak nuclear forces. Now order of strength, it is also very important term, which is more powerful and which is the weakest among the 4. So if I talk about the strongest force, so the strong nuclear force, it is strongest amongst all the 4 forces. Then the number comes out of electromagnetic force, and at the 3rd position weak nuclear force, and at the 4th position the gravitational force. I have a doubt in my mind, maybe it is clear to the audience, but I have a doubt. The order of strength of the gravitational force, that is at the 4th position, but still the strength is lowest, but still the big planets or the whole universe is holding one object to the other object by these forces. So what I mean to say, ये weak forces हैं, सबसे कम strength हैं, but उसके बावजूद भी ये बड़े बड़े ऑब्जेक्ट को स्पेस में होल्ड करने की ताकत रखती हैं. सो दीज फोर्सेस, मेरे ख्याल से तो ये जो फोर्सेस हैं, ये मेरे लिए सबसे इंपॉर्टेंट फोर्सेस हैं कि जो इतने बड़े बड़े ऑब्जेक्ट को विद होल्ड करके रखती हैं, और फिर भी ये सबसे weakest forces में काउंट की जा रही है. So that was the main discussion part of rest of the fundamental forces. So let me take a few questions. So which of the following is a property of weak nuclear force? They are weaker than the gravitational force, they are longest range, they are responsible for beta decay, they are repulsive in nature. So they are responsible for beta decay. This is the main point. Which of the following is a property of weak nuclear force? Weak nuclear force they produces electron. Electron are not present in the nucleus, but still in the alpha, beta, gamma rays emission, beta particle they are coming out from the nucleus. So beta particle they are coming out from the nucleus of the radioactive nuclei of the radioactive material. So because the forces are weak in the nucleus, so due to the weak forces, the neutrons they are converted into so proton and neutron they are converted into electrons, and finally the electron that comes out means electron under hold नहीं किया जा सकता, so it will come out. So it is coming out with the weak nuclear force. Which among these forces has the longest range? So gravitational force has the longest coverage area, longest range from one part of the universe to the other part of the universe. So which force has the highest order of strength? Strong nuclear force has the highest strength. Now I will not take this part of the presentation towards unification of the forces, but I told I am just explaining it briefly. Now all the four forces they are unified together, and when all the forces they are unified together and they make a single force, then that is called unified force or unification of forces. So with this I close my lecture of the fundamental forces in nature. I completed this lecture in two parts. Part one with the gravitational and electromagnetic forces, and part two I covered with the strong nuclear force and weak nuclear force. So now let me take the attendance. Adarsh, Ayush, Manoj,
Present, sir.
Payal, Vansh, Bijalwan. So 1, 2, 3, 4, 5. 5 students I have. So that's all for today.
Thank you, sir.
Okay.